We have a clear purpose of creating safer, sustainable, and connected future. And with this purpose, we try and create impact on four key areas globally. First is transportation, second is energy management and sustainable energy, third is creating factories and homes smarter, and fourth one is enabling the global digital networks. So with this, we are a $16 billion company. Our revenues are spread equally across three regions, and which makes us a truly global company to provide a solution to different customers that has been spread across each three part of the globe. And I refer 2030 is a decade of battery energy vehicles for one simple reason. By the end of 2030, we are expected to witness the exponential growth of battery electric vehicles, and it will reach or in fact even surpass the sales of internal combustion vehicles. What does it means that 2030 is going to be the inflection point where the industrial or the internal combustion vehicle going to get drastically reduced on the roads, and the battery energy vehicles or battery electrical vehicles going to get explode in span of 20 years. Fast forward 2050, and if I have to believe Morgan Stanley's research data, internal combustion vehicle going to be the thing of a past. And this opens whole new market for areas like electric infrastructure, DC charging infrastructure, fast charging infrastructure, and battery swapping. And we are all poised to have this opportunity taken with the help of advanced technological solutions that revolves around sensors and connectivity solutions. In terms of EV infrastructure, in present, there are two technologies that are available. One is AC, which is up to 43 kilowatt, and DC, which ranges up to 200 kilowatt at this point in time. But there are several technologies that are available that can stretch up to 1 megawatt. We can give numerous data points that why these different technologies exist. But for normal consumers, let me explain in a much simplistic manner. For let's assume a vehicle like hatchback, and if it is completely electrical vehicle, and if you use 1.4 kV charger or 2 kV charger, it's going to take you 20 hours of time to fully charge it. If you consider using level 2 chargers, which is at 7.2 kilowatt or 10 kilowatt, then it probably take you around 6 hours to fully charge your vehicle. Then if you really want to fast charge your vehicle, and if you adopt DC fast chargers, which is available around 200 kilowatt at this point in time, then the amount of time that's needed to charge your vehicle is around 30 minutes. So what we are talking here essentially is we are talking about fraction of a time that's needed to get your things done or to charge your car compared to the conventional charging system that was available in last 5 years. So as we see the world going forward with the help of explosion of EV infrastructure, the DC charger going to take the front seat, especially for the public infrastructure, and the lot of connection technologies that are needed to enable this DC fast charger needs to be reimagined, redesigned, and redeployed in next 10 years. And when we talk about connection technology differs with the help of different standards. And it's all interlinked with the application that we use and the country that we want to deploy those applications. And as we all know, in the electrical world, the specifications and standards changing as we move into different parts of the world. 95% of the AC chargers are below 22 kV. And we expect this market to also keep on growing as good as DC market, and we can see rise of 43 kilowatt across all the major countries that we see. Now if you flip the side and if you think of DC chargers, currently the 70% of DC chargers which are used with the help of BMS and battery system are at 120 kilowatt, which essentially means we have a lot of room to develop infrastructure that will be available at 300 kilowatt with the current specification, at 400 kilowatt with the current specification. And if you fast forward the future, then we are expecting the whole CHAoG standard, which is CIDMO 3.0, which is going to get implemented anytime soon, is going to take us to 900 kilowatt, essentially up to 1 megawatt of DC charging, fast DC charging. From 200 kilowatt to 900 kilowatt, or example 1 megawatt, the core infrastructure of the charging lies at the heart of the DC charger is at the AC-DC power converter. And today the AC-DC power converter is at 20 kilowatt. However, going forward, we expect the transition from 20 kilowatt to 40 kilowatt within span of 3 years. So that's the short term that I'm talking. In the midterm, I can see the 40 kilowatt going to get redesigned up to 60 kilowatt. And in the future, it's going to take 100 kilowatt consumption of AC-DC power converters. Now, if you take this thesis, then what are the connection technologies that are needed? So first is high current relay that's going to get needed for such kind of power converter capacity increment. Second is high current 1000 ampere distribution products that are going to get needed, which is UL certified, which is IC certified, and also IP20 products because of a lot of installation and maintenance that's going to needed in such kind of infrastructure. The third is DC contactors that's currently available at 10 and 15 kilowatt, especially those ratings needs to be expanded up to 40 kilowatt as and when it's required. So when we are talking about EV infrastructure landscape, we cannot miss out on one single fact that charging can become wireless in future. And with this wireless charging, there are a lot of disruptions that going to happen in connection technology and which is currently evolving. The second that we see inside of the charging diversity is battery swapping because there is a limitation on grid that you can take energy out of it to feed to the charging stations, which give birth to areas like battery swapping, where the energy is available on demand or on tap with the help of batteries. And this opens the whole new market of battery energy storage and again the renewables market to help support this cause. And with this, we need a strong battery to battery or battery to converter connection system to have the transition effortless between battery and the grid and also from the BSS system. Charging, as I mentioned earlier, there are two core systems, one is AC and DC. And if you think deeply about the DC chargers, then we have standalones and split. However, the connection technology becomes more crucial and complex in DC chargers, especially compared to AC. Why? Because we have multiple products, multiple subsystems, and multiple architectures that has been involved in the charger to accommodate the power flow. Let me give you an example. So if you think at the bottom of the chart between battery to the inverter, we need to have splitter product. And the use of the splitter product is to take input at a higher potential and then distribute it with the different products to load the different applications in the system. If you think of second application in the chart or second number on the chart, these are the connection products simply used for one-to-one connection or RYB connections between filters and the transformer and transformers to grid. Again, this becomes vital for efficiency of your connection system to have those connections in place with the help of right standard specification and compatible for the wires that you have chosen or the conductors that you have chosen. If you come to the bottom of the chart, the third, which represents the core and vital connection system that is present between inverter and the grid, and this is where the technology advancement starts to begin. Here we are not talking about just a connection technology, but the whole different functions and whole different aspects of power monitoring, power conversion, and also power distribution. Here there are different devices available in the market that are used for three different functions. However, we at T Connectivity has come up with several solutions that with one single product we can do tappings, we can do the distribution, we can have the monitoring tab through which we can regulate the flow of the power, and also it can be accommodated with the filters to remove the or fine tune the circuit to become more efficient in terms of operation. Here in this particular range, you can see the products that starts from 80 amps to 500 amps, compatible with different cables and the flat conductors. And if I have to give the actual image or the actual scenario where the products are getting installed in EV infrastructure, so here you can see one product has been installed to cater the 250 kilowatt infrastructure, especially the DC infrastructure, which takes input as a flat bus bar and then regulates it with different type of cables as an output. So this is how the different set of products or different set of solutions that has been used for DC infrastructure. Now with this, I will leave you with one single thought, that connect like the world depends on it, because it really does.